Hi, my name is Dan Malone and I'm just posting this recording in response to the fantastic discussion in the section 1.18 about drug potency. So there's a general consensus, which is absolutely correct, that the lower the EC50, the higher the drug potency. That's absolutely true. So if we plot the effect of a drug versus the drug concentration, then as we saw in the recording, you can see an effect like this, where the more drug you give, then the greater the effect will be. And if you plot the 50% response, then it gives you a concentration that we call the EC50, which is 50% of the maximal effect. And so if that is lower, then yes, the drug is going to be more potent, and it's lower if the curve is pushed this way. So this is more potent, and then if the curve is this way, then it will be less potent because the EC50 would be great. What about the affinity though of a drug? So the lower the EC50, the better the affinity? Well, possibly, but not necessarily. So in terms of, if we think of what affinity is, so here we've got a receptor on the surface of a cell, and if we draw an agonist that binds to that receptor, then the agonist can bind with varying degrees of affinity. So if a drug is very good at binding to the receptor, it's not necessarily really good at having an effect inside the cell, and that's called efficacy. So efficacy is quite important here. Now, if you think of this receptor not as a blue rectangle, but as a three-dimensional structure in space, then it looks more like something like that sort of thing. And so if it's a high molecular weight protein, which they are, then the agonist will bind and change the conformational shape of that protein so that inside the cell, in the case of what's called G protein coupled receptors, which are the most common receptor class in the body, then they will interact with G proteins on the inside of the cell. And the ability of the drug to change the conformational shape of that receptor is what dictates efficacy. So some drugs can bind really well, but not have great efficacy inside the cell. And I'm really talking about agonists here, so drugs that bind to a receptor and activate it to produce an effect inside the cell. So you can have drugs that are really good binders, but they don't have much in terms of efficacy because the way in which they change the receptor shape isn't sufficient to activate the G proteins in the cell. You can also have, though, drugs that are very good binders, and then will be very efficacious in the cell. It's possible to have drugs that are only okay in terms of their affinity for the receptor, but they're still quite efficacious in terms of drugs. And an example of that sort of drug is one called salbutamol. And salbutamol, its trade name around the world normally is Ventolin, and it's used to open up the lungs, cause bronchodilation in the case of diseases like asthma. So salbutamol's got only mild affinity for its receptor, called the beta-2 receptor, but it's got quite good efficacy. So even though it only binds to the receptor with okay affinity, it's got very good efficacy because the way in which it changes that conformational shape is very efficient, I suppose, in terms of activating the G proteins or causing the G proteins on the inside of the cell to become attracted to that receptor complex. Another specific question was a compound with high affinity does not necessarily have high efficacy. That's absolutely true. Is it possible for a drug to have high potency but have low efficacy? Not really, no. It's unlikely. Efficacy really does dictate potency of a drug. So what it can do inside the cell or in a tissue will then dictate what the effect in the body, which is what potency is, of that drug and what that will be. What else? So there's no direct relationship between potency and affinity. Is this correct? Well, pretty much, although you have to have some affinity. To have potency in terms of agonists, you need to have some affinity. If a drug has really low affinity for a receptor, then it's pretty much impossible to have any sort of decent potency. A drug can have high affinity and low efficacy. I mentioned the case of salbutamol's low affinity and good efficacy. So no, high affinity and low efficacy is not. It is possible. Sorry, if you have high affinity to the receptor, it's not necessarily the case that will affect the G protein inside the cell. Depends on how well it changes the conformational state of the receptor, as I mentioned. So just in summary, also bring up the point of a couple of different drugs. One called morphine, which you give about 5 to 10 milligrams to a patient, and that will generally give good pain relief if that's what it's being used for, as opposed to paracetamol, or what's called acetaminophen in the USA, where you have to give 500 to 1,000 milligrams, more likely 1,000 milligrams, in order to get significant pain relief. And so clearly morphine is the more potent drug because you have to give a lot less of it, so its concentration effect curve will be up here, as opposed to paracetamol, which would be out here, because you have to give more of that drug to have an effect. Now, when judging the relative merits of a drug for a person, health professionals such as doctors consider many other factors, not necessarily potency. So potency can lead to more toxicity, for example, or more side effects. So other factors are important, such as cost and duration of effect and other factors as well. I hope this has been of use to you. I'm really enjoying reading all the comments, and hope you're enjoying the course.